We have multiplying radicals today. So we have talked about adding and subtracting. So what we're going to do now is multiplying. Adding and subtracting has quite a few rules. They have to have the same radicand. They have to have the same index. Multiplying has much fewer rules. The indexes just have to be the same, but the radicands do not have to be the same in order to multiply them. So 3 steps. First step, you're going to multiply the outside numbers. Second step, you're going to multiply the inside numbers, multiply the radicands together, and then simplify, also known as make trees. You can make trees and simplify before you multiply, but the likelihood that you're going to have to make trees and simplify again is pretty high. So it's just more work to simplify, multiply, and then simplify again. So that's why we're going to multiply. We might have some bigger trees, but at least we only have to make trees once. So I have my first example, the square root of 3 times the square root of 15. I don't have any outsides, so 1 times 1 is still just going to give me 1, and then 3 times 15 is 45. Tree out 45, I get 3 and 15. 15 is 3 and 5. My index is not there, so my index is 2, so I'm going to circle my doubles. So 3 goes on the outside, 5 is my leftover, and it goes underneath. So that is 3 times the square root of 5. And that's it. Next example, 3 times the square root of 12 times 4 times the square root of 15. You're going to multiply your outsides together first. So 3 times 4 is 12, and then you're going to multiply your insides, 12 times 15. Probably need a calculator for that, but it's 180. So this is just showing you where it came from. The 3 and the 4 created the 12, and the 12 and the 15 created the 180. So now I'm going to tree out 180. That's 2 and 90. 90 is divisible by 2, so that is 2 and 45. 45 is not even, so we can go 3 and 15. You could go 5 and 9. Either way, you'll get the same thing. 15 is 3 and 5. So now I have all of my primes. My index is 2, so I'm going to circle my doubles. So I have a double 2, and I have a double 3. Those groups go together. So 2 times 3 would give me 6. And then I multiply it by the 12 that was there. So there's the 6, and with a leftover 5, multiplying by the 12 that had already been there when I multiply them together, and I get that that is 72 times the square root of 5. Does not change my radicand because I simplified it. 5 was my leftover, but 12 times 6, the 6 came from my 2 groups, the 12 came from what was already outside. Now I have 2 that I want you to try. The answers will come up in a short while, but go ahead and pause the video and try it. This first one ends up being negative 3 times the square root of 10. Negative 3 times 1 just gave you negative 3, and then 2 times 10 gave you 10. You could tree out 10. It's still just going to give you 10 now. The other one is a cube root. And so when you simplify and you take things out, you get negative 2 times the cube root of 4. Okay. So these are very simple, just two things multiplied together. So we're going to take it up a slight notch. So now let's talk about what happens ones where we're going to need distributive property. I have parentheses. To get rid of the parentheses, you're going to do distributive property. It is no different when you have radicals. You're still going to do distributing to the first, distributing to the second. You're still going to follow the same rules. You're going to multiply your outsides, multiply your insides, and then simplify. So I'm going to do the square root of 10 times 4 times the square root of 5, which is going to give me 4 times the square root of 50. 4 was on the outside. 4 times 1 gave me 4. 10 times 5 gave me 50. And then I'm going to multiply the square root of 10 times the square root of 2, which is going to give me plus, because I'm just going to bring down that sign, square root of 20. Now I'm going to tree out the 50, and I just need some room, so I'm going to move it over a little bit. So 50 is 2 and 25. 25 is 5 and 5. Simplifying that, my index is 2 because it's not there. So that 5 times the 4 that was already there is going to give me 20, and I have that left over 2. Now I'm going to tree out 20 to see if it can go with that 2. Remember, they have to have the same radicands to be added together. So I have 2 and 10, which is 2 and 5. Again, my index is not there, so my index is 2, so I'm circling my doubles. So I have 2 square root 5. My radicands are not the same. They can't go together, so it's just 20 square root 2 plus 2 square root 5, and that's my answer. Another example, I have negative 4 times the square root of 15 times the quantity 4 square root 6 plus square root of 10. Distributive property again, going to multiply it to the first term, multiply it to the second term. So, same rules apply. Multiply your outsides. Negative 4 times 4 is going to give you negative 16, and 15 times 6 is going to give you 90. Multiplying it to the second term, negative 4 times 1 is going to give me negative 4, and 15 times 10 is going to give me 150. I did bring down that plus sign because that's what you're going to do. You're just going to bring down that sign. But if you'll notice, when we get to the end, plussing a negative is going to end up making a negative, so we'll make it work in just a second. Needing some more room, so I'm just going to move it over. 90 is 2 and 45. 45 is 3 and 15, or 5 and 9. And 15 is 3 and 5. Index again is 2 because it's not there, so there's my double. So that 3 times the negative 16 that was already there is going to give me negative 48, and I have 2 leftovers. I have a 2 and a 5 leftovers, so we're going to multiply those together to give you 10. All right, so there's my first term. Simplifying my second term, 150 is 2 and 75. 75 is 3 and 25, and 25 is 5 and 5. Again, my index is 2, so I'm circling my doubles. That 5 times the negative 4 that was already there is going to give me negative 20, and then 2 times 3 is going to give me 6. Plussing a negative is going to make it just be a negative or a minus, and so it's going to go away. Those can't go together because I have a radicand of 10 and a radicand of 6, and so that is it. It looks really ugly, but it's not that bad. All right, so these are the last 2 that you can try on your own. The answers are going to pop up very shortly. So the first answer is 5 square root 3 plus 4 square root 15. And then the second one is 5 plus the square root of 30. These are not getting any harder than these, so go practice this.